Hello? We're starting. Okay, welcome. My name is Shaun Smith. I'm with Oracle, and I'm going to talk to you today about work we've been doing in the EclipseLink project to support RESTful persistence. So if you haven't heard of EclipseLink, it's the JPA 2 and 2.1 reference implementation. So it's shipped as part of Glassfish, of course, Glassfish 4 and Glassfish 3, providing JPA. If you know anything about reference implementations, it's the piece of code that must be finished, must prove that the specification works before the specifications are signed off as complete. So it's a proof, an existence proof that the specification is tractable, is doable. So EclipseLink provides that. And it actually also ships in Oracle WebLogic in the 11 and the current 12 series. And we started the EclipseLink project from Oracle TopLink. So I joined Oracle when, before the open sourcing, I was part of this open source effort to take Oracle TopLink, which had been around for many years, and open source it at Eclipse. So all the packages changed and all the code was checked for IP, quality, etc. And what that means is that EclipseLink is on version 2.5, is the latest shipping version, the one that went in Glassfish, the one that implements JPA 2.1. But it's actually quite an old code base. It's quite a mature code base. It had been in use for at least 10 years or more at the time it was open source. So it's quite a mature code base that the number 2.5 or the version 2.5, the current version, doesn't really make clear. And it's EPL and EDL licensed. So it's the Eclipse public license, which is common for most of the pieces in Eclipse. And it's also EDL, which is a new license, or a new-ish license. It's new since EclipseLink joined the Eclipse Foundation, because it's a Berkeley-style license. So it was licensed in a very liberal fashion so that people could reuse it. In particular, it could be used in Glassfish and then licensed to Java EE licensees. So it's very, very liberal license, and you can really do whatever you want with it if you so wish. It includes JPA and JAXB implementations, and some people are usually surprised, because we had built this very powerful sort of mapping engine inside of EclipseLink for doing relational to object. And the need for mapping to XML came along, dealing with mainframes and other legacy systems, and that evolved into a full JAXB implementation. So it's JAXB compliant also. So it's got a couple of pieces, and we're going to see both of those in the presentation today and see where they play. So this slide sort of gives you the context of what I want to talk about. And we're talking about RESTful persistent services, so data services. I want to take data that's in the database down here, and I want to send it to the browser, and then I want to manipulate it in the browser. So I'm building thin server architecture applications. That's my use case. That's the target architecture. The logic's in the browser. The domain logic is in the browser. The back end is providing data services to the web browser application. So probably JavaScript, perhaps Dart, right? Anything that can talk to the server and get data. And so I want to go from the database up to the browser, run my logic, manipulate the objects, add new ones, delete them, change them, and then I want to send them back to the database for, obviously, persistent storage. And I want to do this without losing any data, without any kind of corruption. I want this to be a very smooth, easy-to-do operation. And on the surface of it, it seems, straightforward, right? Sounds like a simple idea. It turns out it's not as simple as we had hoped. So of course, I'm going to use Java on the server. So I have a sort of Java layer here where I'm going to have some code, my Java objects. And I'm going to use EclipseLink JPA to provide JPA. So I'm going to go between database and Java using EclipseLink. And on the front end, talking to the browser, I'm going to use JAX-RS, which is part of the Java EE stack. And it's going to give us HTTP services, REST services, talking to the browser and over to Java. And then the other piece that's missing here so far is the binding. So I'm going to need to go from Java objects into XML or JSON. So what I really want to do here, well, I should say, just going back, so I'm going to use EclipseLink JAXB and JSON binding, and that's implemented by our MOXY component. So we named this component before we did JSON. So we had mapping objects to XML MOXY. And now we support JSON too, so the name just means MOXY, which is kind of like, sort of a you can do it, like sort of a can-do attitude. So I'm going to use EclipseLink MOXY to do Java to XML or Java to JSON. So this is the stack I'm going to work with, right? So what I'm going to do is I'm going to take database data. I'm going to use EclipseLink JPA to give me Java objects. Java objects get turned into XML or JSON by MOXY. and then JAX-RS is going to do the HTTP transport for me and offer the services over the browser, right? And I'm going to get Java. I'm going to get objects on the browser to manipulate. So that seems like a pretty reasonable stack, and it lets me achieve this, right? So I've got these pieces in the middle, and this is a pretty vanilla-looking EE application. JPA, Java, some JAXB, and some JAX-RS. All the buzzwords, right? It's all pretty straightforward. So this is the stack we're going to work with. What I'm going to do is I'm going to use this as my agenda slide. So this is going to be sort of our guide. We're going to go through this stack, and we're going to work our way up. We're going to look at some of the issues you would encounter if you were to take sort of any JPA provider, any JAXB provider, any JAX-RS provider, stick them together in a stack like this, and try and do what I want to do, which is get data out to the browser and back. So we're going to start at the bottom, and in fact, we're not going to do much at the bottom. So I think that there's nothing very exciting going on at the bottom part of the stack, which is the database into Java. So JPA addresses object relational mapping. I've been doing that for like a long time. It's a well-worn area. We all have used, Hibernate or TopLink or Codo before, OpenJPA. There are impedance mismatch issues that we're all very aware of between database model, the relational model, and the object model. And JPA accounts for most of those things. So we have techniques that's pretty well understood. We can go from database data into Java and back again without losing information. We have a nice transformation, right? So that transform is understood. So there's nothing new to learn here. So we're going to move up the stack. So let's look at MOXY and what it's going to do for us. So it is, as I said, it implements JAXB. It also implements a JSON binding framework. And if you're following the Java EE specifications, Java EE7 included JSON-P, which is a new standard, the 535 there, which is processing. And it's a parser, essentially. So you get the output of processing JSON with the JSON processor API is of a DOM tree, as it were. You get JavaScript objects. It's kind of like a DOM, like you would from JAXP, right? The the XML parser spec. JAXB sits on JSON-P. So you get a parser, and then you get binding into Java objects. So with JSON so far in the EE standards, we only have parsing. We don't have binding. We can't make Java objects directly out of JSON today. There is definitely moves to write this spec or have this spec move forward, and hopefully in Java EE8. But today there isn't one. But we went ahead anyway because it was actually straightforward for us to do so. This is one of the things you do, is if you can do it easily, well, you might as well go ahead and do it. But we had a need for JSON. I think we all have a need for JSON. So what we've done today is we are interpreting the JAXB annotations for JSON, which is a pretty common technique. There's other people who are out there doing the same thing. So we're able to take a JAXB annotated set of classes, and through the selection of the media type, the content type on the marshaller or unmarshaller, we can read or write either format. So that's what we've implemented in MOXY. So it lets me do this. And I think that's pretty good. So I can take a Java class here, customer, and I can produce either of these, right? The XML or the JSON. Now, when we first did this, of course, the JSON we produced looked kind of like XML, like a lot like XML. And you can see on the XML side, there's actually an extra layer of nested elements here. So I have phone numbers, and then I have a phone number element wrapping each phone number. It's a list, right? I have a list of, or a set here of phone numbers. In the JSON side, though, that's really unusual, right? You wouldn't do that. Proper idiomatic JSON would have an array of elements, right? So you would not have phone numbers and then an extra layer of phone number and so on and so forth. So that's controllable, and you can do that. You can control whether you want that or not with EclipseLink. It's an option. So we can go between the both using the same set. So that's great. I can produce XML or JSON, but it's not that easy to use it with JPA necessarily. So it's great for Java, but what about JPA entities, which is what I'm being fed from the back end? And so there's a few challenges here. There are a few things that we have to deal with. If you're doing sort of model transform, if you think of this in terms of transforming models, I can go from a relational model into a Java object model with JPA. I can go from a Java model into XML or JSON with sort of JAXB or MOXY here. But there's some things that aren't there. There's some things in the model that aren't there. So a relational model has the idea of composite keys or even embedded keys in JPA. Those don't represent very well in XML, or at least in standard approaches really doesn't model it very well. So we've added supports explicitly in MOXY to model the idea of composite keys or embedded keys. A second problem we faced with dealing with these JPA entities we're getting from database is bytecode weaving. And this is kind of a self-inflicted wound or problem for us. It wouldn't happen if we weren't using JPA, but it turns out that most JPA providers do some kind of bytecode manipulation to your classes. So if you create a persistence unit with 5 or 6 classes you want to be persisted with JPA, at runtime, possibly at compile time, some bytecode manipulation will take place. And what we're going to do is things like we're going to inject proxies to do lazy loading. We're going to cache values on objects that may help us look them up in caches more efficiently, maybe secondary cache lookups values. We're going to do things like dirty checking or change tracking, a whole bunch of things that you don't see, and you don't want to see them. They're just this infrastructure, right? We're doing these things. But the problem is we are changing the classes, right? So if you go in the debugger, looking at a JPA entity, you will see, in EclipseLink anyway, you will see extra fields that you didn't write that are in there. And you can ignore them. But when you hand one of these objects to a JAXB provider, let's say the Metro provider, which is the one that's in the JDK, it will try and marshal those things. The things that have been, these artifacts will try and get marshaled. And this is a classic case of, two libraries or two frameworks colliding, right? JPA is doing what's good for it, optimizing performance, bytecode weaving, great. You hand it to JAXB, it introspects the object, looks at the fields, and starts to marshal what it finds. And some of those things are references to other objects that are infrastructure, transactions and all kinds of things like that, sessions. So that's a bad thing. So since our team, the EclipseLink team, works on both JAXB and JPA, we are in a good position to sort of resolve this mismatch, this problem. And so we have a very simple solution, which is when we're doing bytecode weaving, we're injecting XML transient annotations into the bytecodes. So we're basically doing what you would do manually, saying ignore this, ignore this, ignore this with an annotation. We actually add that in. So the EclipseLink JPA objects don't confuse JAXB, and they don't expose anything to JAXB that you didn't write, which is good. Now, it would be nicer if there were a more generic sort of ignore this annotation. It's kind of very specific. XML transient is obviously a JAXB annotation. And it would be nice if there was something that when some other framework comes along trying to manipulate JPA entities, they don't have the same problem. They might have the same problem if they're using reflection to try and, say, serialize or marshal or manipulate in any way. And the third thing here is this issue of bidirectional or cyclical relationships. Now, here's an example of a very, very typical JPA set of classes. I have 2 classes here. I have customer and phone. And customer has a collection of phones, right? And a phone has a reference back to the customer. This is pretty normal. The relational model supports this very easily, of course. We have probably a phone table with a foreign key back to the primary key of the customer. And when we read a customer, when we're getting the phones lazily or eagerly, we will select from that table. We'll select all the rows with the right foreign key. So this is very normal, but there's a bit of a problem in that JAXB doesn't like cycles. JAXB, the approach for JAXB is it will cyclically, or it will depth first search traverse a graph, marshalling it into XML, or in our case, JSON. And so what happens is if you pass this to a JAXB provider and say, marshal this, you'll get a Stack Overflow. Or you would get something, or if you have a customer with some phones and the phones point back, if you have that structure, you'll get Stack Overflow, or in EclipseLink's case, we actually detect the cycle and fail because there's no stopping condition, right? It's going to go forever. So this is a problem. What are we going to do about it? Well, back to XML transient again. The standard solution with JAXB would be to stick an XML transient on the back pointer, right? So as you're sort of marshalling down from the top, you marshal out a customer, you get some XML, they get the list of phones, JAXB is iterating over the set of phones, and when you get to phone, it just doesn't look at the customer, right? It's ignored, nothing happens, which sounds like a solution, right? But unfortunately is not. So the problem is this. I want to talk, remember my story is I want to go from database to the browser and back again and not have a lossy data. So if I have this in memory, this customer with phones and the back pointers, If I marshal it out to XML, and then unmarshal it back into Java, with an XML transient, that reference is gone, right? So as you unmarshal, I got this nice hierarchical structure, and we're unmarshaling the customer, and we get the phone, it completely ignores the back pointer, and you get this. So that's a bit of a problem because I want to be able to go between these different formats and not lose stuff. Because if you take the unmarshaled object graph here that has a missing pointer, and if you try to use JPA to do a merge, so you try to say apply the changes. So on the client side, they've made some changes that change the customer's phone number or something, or something about the customer. You try to merge those changes back in. If you have a missing relationship, it implies deleting something. It means something's changed in the model, and you'll see if you tried this with JPA out of the box, you'll see that a delete occurs on some column. Some value will go, and that's bad, right? This is a side effect of what we're doing with JAXB. So what can we do? Well, we have a fairly simple solution. This is an EclipseLink specific solution, but we went and came up with sort of the inverse, or sort of an analog to what JPA does. JPA describes both sides of a relationship, and so we've done the same in a sense. We add this XML inverse reference annotation, which tells the JAXB provider that, customer on phone is a reference to its containing object. It's contained by, it's contained in this case is customer, and it's pointed to by the phone's attribute. And this is a very simple annotation. It just really is declaring that there's a bidirectionality here that needs to be dealt with. And so with this annotation, what we can do, click, okay. What we can do is the same thing, take the same initial model, we marshal it out, marshal it back in, and what happens is when MOXY JAXB is unmarshaling the phone, when it sees customer, and because the XML inverse reference, it understands, okay, I'm unmarshaling this object, I'm in the context of this wrapper or this outer object, I need to replace the back pointer to the containing object to put him back together the way he was. So now I can go between these two formats, in-memory Java objects, a flat file, say, full of XML, and back to Java objects and not lose anything. And you could do this manually. You can manually, you could use XML transient, and you could post sort of unmarshal. You could walk the graph yourself and repair the missing pointers if you know what they are. But this is a very simple solution, just sticking annotation saying that needs to come back, but don't marshal it because if you do, it's going to Stack Overflow. So with that, let me just give you a little bit of a demo what this looks like. And I'll also give you a demo of the JSON while I'm there. So let me flip over here. Brave, I'm going to bring up Eclipse on stage. So I've got an example here. I think that's pretty good. I can't really do much about the Explorer size, but I have a simple JPA persistence unit here with a customer, an address, and a set of phone numbers, right? So there's nothing very fancy about these classes. The thing that is interesting about them is I have customer here. It has both XML root element and entity on it. So I'm mixing both JPA and JAXB annotations, and typically I would not recommend you do this. Not if you are compiling schemas. So a lot of people working with JAXB will compile a schema to get their entities out. And then if they want to then persist them with JPA, they put annotations on those generated classes. And the problem with that is, of course, if you recompile the schema, then you end up deleting all of your annotations, your JPA annotations. So if you are working in that mode, compile the schema, and then capture all of your JPA mappings as XML, right, in a mapping file. So that way it lives beyond your the life of the Java class itself if you regenerate it. And the nice thing is in Eclipse, if you're using the DALI or the Web Tools platform JPA tools, if you do that and somehow you change the schema in such a way that your mappings are broken now, your JPA mappings, you'll get red marks telling you what's not working anymore. So anyway, this is a bit weird. It's a good example of why too many annotations are not good. But here's a named query, right? Typical JPA stuff, and XML root element. And here's my address. I have a reference to an address, and I have a reference to the phone numbers. And you notice I have some little JAXB annotations here telling me how I want to format the text. And you saw that in the snippet of code there. I want a nice wrapper, phone numbers, and then the elements are going to be phone number in XML. So I have all that there. That's great. And if you take a look at phone number, it does have this XML inverse reference. So I'm going to take it off first just to show you that without that, what do you get? So that's my model. And the code here. There are a couple pieces of code here. So I'm going to marshal. I'm going to do, that's good. I'm going to do something like this here, which is I'm going to go to use JPA to find the customer, and I have one in my Derby database here. There's just one, and I'm going to read that customer. Then I'm going to create a marshaller, JAXB marshaller here, and I'm going to set it to format preprint, which is nice. I'm going to set a couple of EclipseLink options here about the JSON. So I mentioned that you can have wrappers or not have them. I don't want them. You can also suppress sort of a root element, which in JSON the root doesn't really have doesn't have a name. It's just braces, curly braces. And I'm going to dump into a file. And here's the interesting part. I'm going to set the media type. So this program takes on the command line either XML or JSON, and it'll just set the media type, and then I'll get whatever I want. So I'm going to dump that onto the disk, and then I'm going to open up the browser. So I have one object in there, and I commented out the XML transient. So if you do that, I guess I can run it here just as well. Yes, I have a couple of run configurations. So XML, so it runs, and it's not good, right? So it figures out there's a cycle because it's going around that loop, collection, element, and eventually we stop. So I have an infinite loop. So I could go through the process of, the more complicated process of XML transient and then run my own code to walk the graphs, but I'm lazier than that. And the goal of frameworks is to make your life easy, so I'm just going to do that. And now we've explained the circularity here to JAXB, and I can marshal that up. Okay, so what you get is just that. That's what you expect. So I've got, this is a text editor here. So I went to the database, I read an object, and actually I think you sort of saw it fly by way down here. You saw some select statements as you read these things. But we have some XML. So what's fun about this is, okay, imagine I've sent this over to the browser. Right? This is where I'm going with this. I've got this XML document. I made a REST call. I'm sending it to the browser. Someone changes this stuff, right? So, they change the name of my person here, my customer, and I save the file. Excuse me. So I make a change, and then I send it back. And so I'm going to unmarshal. So I'll show you that code here. So I guess I will. There we are. I'm going to do the reverse, the exact reverse, right? I'm going to get a marshaller, or unmarshaller in this case. I'm going to say I'm reading XML or JSON. I'm going to go and read it from the file and go dig out the customer. And then I'm going to go and merge it. Take the customer and merge it into the persistence context, commit, and JPA will detect any changes I make to this object graph, that's part of the merge process, and apply the minimal SQL to propagate that change down to the database, right? So I can run this too. Now why I'm showing you this is because this is the underlying technology that I'm going to get to in terms of REST and what we're going to talk about for the interesting part of this. This is the nuts and bolts of what's going on. You can use it yourself. So if I unmarshal this XML I just wrote, it's going to read the file. And let's see here. So you see here we see the customer name has been set to Tim. So JPA does this job and merges the graph. So that's great. Sadly, we get a lot of select statements because since we're not running a real application server with no caching, I have to kind of go dig everything out of the database to find out what changed. I have to compare. In an application server environment, this would be much more efficient, but there's no state here. So that's the basics of what we have. I'll show you the JSON briefly here. It's exactly the same thing. I can marshal JSON. I just set the media type. I get some JSON. And I can do the same operation here. Notice I do have the change from before, from the XML side. And having done that, I can then run the other side of it, which is the unmarshal. Unmarshal some JSON, reads the file, gets some objects. JPA has no idea where they came from, detects the changes, and again we see the name change. So this is what's going on. This is nice, round trip, relational model into Java model, into XML or JSON model, and back and forth, and there's no data loss, which is the critical piece. Okay. So let's move up the stack. So this is sort of nuts and bolts. So we got this far, right? I can produce XML or JSON. Now I want to get over to the browser. So I'm going to use JAX-RS, of course. Now, who's using JAX-RS here? People are using it? Yes? Okay. So I'm probably lazier than you, so I don't like writing a lot of JAX-RS code, but I'll show people who don't see JAX-RS, I'll give you a sort of a crash course in what it looks like. If you were doing JPA, right? So I have some bean to get invoices. You can read an invoice. And so I've stubbed it out here with a null, and my signature is I'm going to read an invoice for a given ID. So let's say it's a stateless session bean, and I have some injection going on, so I'm going to inject the entity manager. So this is my JPA part, right? JPA fine for an invoice with an ID. That looks pretty good. Now I want to expose this over REST. I would put an @path annotation on this class. And now what I'm doing is I'm binding this bean to this path. Right? My application context / invoice is bound to this bean here. And you see in the bottom. And then, if you can see in red here, I've put an @path on the method, which is binding sort of more, it's refining the path. So /invoice / a value who's going to be bound to ID variable here would be bound, well, almost bound. Those who know JAX-RS, I know I got the order wrong here. It's almost bound to this method. And you notice the @path param does the injection. So JAX-RS will take the value off of the URI here, so the 4, and actually bind it to the ID value on the method, which is really cool, right? It's actually very, very cool stuff. And then I'm going to say that when you do a get operation, so when you get an HTTP get for that URL, I want to basically I want to invoke this method, and I want to pass the int down. And this is basics of JAX-RS. It's very nice. It's very straightforward, right? It looks pretty good. One more step is I want to tell it what I'm going to produce. So in this case, I'm going to say that this method will return XML. So there's actually a lot of defaulting in JAX-RS. If you say this, then by default it'll use JAXB to marshal the result. Okay, so in this case, the invoice will be marshaled with JAXB. So that's cool. So what does it look like, sort of the flow? Well, you make from your browser a request. You make a get for invoice 4. JAX-RS looks at the path, figures out, okay, invoice. You map that to a given bean. It goes and gets it maps to an instance. Goes to the bean. It maps the fact that you've said /4 and get, or maps the get to a particular method. We annotate it with an @get, and it binds the parameter. And then inside that, our code runs, right, the JPA code. So it goes, and the bean uses the JPA API directly and goes and queries using the model, the counting persistence unit perhaps we have here for these invoices. And then we go to the database and get the data. So that looks pretty good. So you can sort of do this. You can build the application we're sort of looking towards with the pieces, except that that's not enough, right? So that's one method. I can get an invoice. If I'm building a real application, I probably can create an invoice, delete an invoice, update an invoice. So I'm going to have more methods, right? I've got to write more of those things. And that's only one object. So let's say I had contracts, payments, invoices. I have any number of things in my domain that I want to expose over REST. I'm going to have to write a lot of methods. So it's all boilerplate code, right? You saw that code. It's pretty much the same code each time. If you're really just vending out data, and it's not logic, you're not exposing EJBs here, we're talking about data services, then really this is just boilerplate, tedious sort of code you'd have to write. So I'm against that. So let's look at our stack. So far we can go from the database, using JPA, get to Java. Java can be turned into XML JSON, goes to the browser, but there's a lot of work, right? So the JPA part was mostly just some annotations on the classes. That's pretty much the work. The MOXY part wasn't even that bad. The JAXB part is annotating the classes. That's not so bad either. Really not that bad. But the JAX-RS part actually was pretty tedious, in my opinion. There's a lot of code to write, not just going to the classes, but actually writing services and exposing individual REST operations. And so what we did was, we said, well, we can figure this stuff out. Like, we know a lot of stuff, right? So if we have JPA metadata, then we can just spin up the whole thing from that. We can just go from bottom up and spin the whole thing. So that's what we did. So we have this JPA-RS or JPA RESTful Services feature in EclipseLink. And what we did was we said, if we look at the JPA annotations, we have an idea of the structure of the objects. We understand their relationships to each other. We can deduce a good JAXB marshalling meta model, or the metadata. And we know exactly what we want to expose. So we can just spin up REST services. We can use JAX-RS, but we're going to use it as a framework, an underlying framework, rather than having the end user program directly on JAX-RS. So we use the full stack. We're just basically automating the whole process, so you don't have to do anything. So what JPA-RS does is it automatically provides REST, all the REST operations, right? So get, put, post, etc., for your JPA entities. And like I said, it automatically comes up with the XML or JSON, and because it's also EclipseLink, it knows, for example, to do things like use XML inverse reference and other kinds of things to avoid lossy transformations. So we have no lossy transformations. And then, of course, it'll publish an API for your application automatically. Now, a couple more features. If you have named queries in JPA, so you can write named queries, we'll expose those for you over REST also, so you can actually invoke those and build parameterized queries. I'll show you an example of this. If you're caching in a cluster, if you have a clustered environment and you're using this, EclipseLink has clustered caching support. So if you're building a large sort of scalable REST-enabled data service, you can take advantage of the clustered caching data. So as one node caches data or changes data, the other nodes can keep up with it. So you don't have to be out of sync. And the last thing that's really interesting, and we're going to spend some focus on this, is we automatically inject links. So we're looking at this HATEOS, right? I think that's how you say it. No one actually knows how to say that, but I'll say HATEOS. This sort of hypertext approach to REST, right? So we're taking a relational model, we're building a Java model, which is what we sort of prefer. That's the model we prefer. And now we're mapping it to a REST model, the REST resource model. So we've taken an approach where each entity, I admit this is a naive approach, but it's a step one of the process. We've mapped each entity as a resource. It has a unique ID. It's required by JPA. So you should be able to get, put, etc. You should have all the usual REST CRUD operations for each entity. Objects that are embeddeds, that don't have identity, they're part of another entity, JPA entity, are not resources. So if you fetch something that has embedded objects, they come as one unit, which makes some sense. So we've done this by default. And so it's sort of like this. I have a database, I have a foreign key. In JPA, that's a pointer. And in the produced, in this case, I'm going to use JSON, the output gets a link. This is pretty normal stuff. We're auto-generating these. So what happens is if I marshal up, say, the customer, I end up with an address item or element in, I guess attribute, sorry, in JavaScript and JSON, and that contains a reference to the associated, say, address. So for all the objects that are other entities that are being referred to, the browser gets, or over REST, what you get is a structure like this. Now, that's actually the easy part. What's cool about that is you can send them back to the server. So I can send out to a browser a bunch of different entities, and they all look like this. They all have like references to each other. You can play with them, manipulate them, and send them back. We'll understand, basically go the other way. This link, this address here, this link refers to a real object. So when we're merging back the objects into the persistence context to sort of propagate the changes to the database, we know how to do that. So we don't lose anything, right? We're going to a sort of a weirdly Java object pointer model. In the browser, it becomes sort of a textual reference. But when we send things back to the server, those textual references get turned back into real pointers again, and then we understand the changes. So this all happens automatically. I'll show you. And the way it happens automatically is we just have a little web fragment. So what we do is you drop a little web fragment, or I'm using Maven. You reference this web fragment. It has about 2 classes in it, and you put it in your web application. If you're deploying to, say, Glassfish or WebLogic that both contain EclipseLink, then this web fragment will basically register the services. It will examine the JPA metadata. It'll create a JAXB mapping model. It will work with JAX-RS to produce all the services, and you're done. So basically, there's no code to do any of this. In fact, there's no JAXB or JAX-RS, just JPA. So what we do is slightly different, right? So we're sitting behind JAX-RS. So you can think of it like a dispatch servlet, right? So JAX-RS gets asked for, and right now I'm using this word here, persistence, to indicate everything that's being under this sort of root path here, persistence, is going to be routed to JPA-RS. So if you say persistence / accounting invoice 4, slightly longer and different URI than before, JAX-RS, we register with JAX-RS saying anything with persistence comes to us. We get past this path. We parse off accounting invoice 4, and we say, okay, well, accounting means they want to talk to things that are in the accounting persistence unit, because you could have many persistence units in your application. We look at invoice and say, oh, they want to operate on an invoice entity, and they're looking for, if they're doing a get, they're looking for number 4, right? So we go ahead, we basically do the find, like you saw before in code, for you, and then send it back across the wire, right? So it gets marshaled up using the mapping model that we came up with. So, click. What's cool about this is this scales pretty well, because if you had multiple persistence units, so you've got a big organization, right? So before I said, oh, well, what if we had one persistence unit with lots of classes? That's a lot of JAX-RS code to write. But what if you're in a proper enterprise where you have a lot of persistence units for different departments? It means that for zero code, I can expose REST for these things, right? For each of these persistence units, if you deploy them in your application, if they're in an application with this web fragment, boom, the services are just there. So this is nice because it's no cost to me. Okay, let's look at a demo. So there's a few things in here I'm going to give you a look at, and I think we're good for time. So this is the model for this demo. It's pretty much the same as before. I think customer became employee. I don't know why we keep switching, but I only need 3 classes to demo these things. I need a one-to-one, one-to-many, this kind of thing. So I have an employee, collection of phone numbers, a single address, and there's other things like employees have other employees who are their managers, but we're not going to look at that today. That's fine. So let's go over into Eclipse and the browser here too. So what I've got is like before, but there's a bit less actually. So I've got this model here, employee address. Let's see here. Here we are. So I've got employee here. I've got address. There's an employment period. It's a embedded class with a start and end date. Nothing very exciting, but we have all these classes here, right? They're all mapped. So all the JPA. If I open up here, well, let's go. Big fonts and zooming. Don't do it. Okay, so here's my class. There's no JAXB in here, right? That's the key thing. There's no JAXB. It's just JPA. So I have a secondary table annotation. So this class actually lives across 2 tables. This is from the standard EclipseLink sort of all singing, all dancing domain model that does all kinds of stuff. So this class specifically is spread across 2 classes to show that feature. There's a number of queries here, named queries that are predefined. Notice the parameters. Oops, like here. We have a like query with parameters, which we'll see in a second where that comes in. So it's just JPA, right? So there's nothing else in here. It's just plain old JPA. So I've got that in one. This is a Maven project that produces a jar. So this one just produces a jar with these classes in it. That jar, the domain jar, is deployed into a web application here, this other project. And it's all JavaScript. So there's actually nothing in here. There's no Java, and there's no... all we've got in here, if I go into the... here, deployed resources, web app. So I've got some CSS, using Twitter Bootstrap. I've got some... Well, I'm actually using AngularJS. Now, they were joking in the Java posse, there's like 25 talks or something with AngularJS. I guess I can add myself to that list, because it's an AngularJS demo with Twitter Bootstrap. And... so here's Angular here. And I also have learned to not depend on the wireless, so I've got them locally installed. So someone reminded me today, I'm like, right, don't depend on wireless. So that's all that's really here. So if I build this thing, it's actually built. It's all built here. Let's go. Now, that's... No, everyone can see the bottom of that. That's great. Okay. So... Oh, and I'm in the wrong place. So I'm not gonna do this one. I'm gonna switch over here again. Sorry, that's the old demo. It's built. You'll see I have a target here. So I built it, and I've got a little war. And what's in the war? You look at the Maven target here. is webinflib, right? So it's got my domain model jar, and it's pulled in the JPA-RS fragment, which is a fairly small jar. Actually, how big is that? Can I find out from here? I think so. So it's 20K. Is that right? I think that's right. It's a 20K fragment. So I can take that and I can deploy it into anything running with EclipseLink in it. Now, for me, that's WebLogic or Glassfish. And to avoid going into upgrading the demos to JPA 2.1, I used WebLogic because it's running JPA 2. So I've deployed it over into WebLogic. So it's over there, and I just deployed it. I went into the console and I deployed the application. And that web fragment got controlled, did all the magic. So what happened is, on top of the REST services, there's a whole metadata API that we automatically produce. And I'll give you a look at what that looks like. Oh, I need to maximize here. So I have the web context here, persistence v1. It's a versioned API, so we can tinker with the API, and that's something we definitely need to do here. And I can just go to the root and do a get on that root. And what I get back is a list of all the persistence units that are deployed in that web application. So in this case, I actually only deployed one, so I only have this employee one. But I get a link here to the metadata for it, so I'm going to hit that. And what I get back is I get a list of all the entities that are deployed, right, that are accessible for me. They came from my persistence unit. So I have employees, I have phone numbers and address. I can take a look at employee here, do a get on that. And so here's employee. This is metadata. This isn't an individual employee. This is actually the metadata. And it's all being derived, right? So I have an ID, it's an int, first name is string. Some things, as we go forward, and this needs some work. This is like I would call this sort of a 1.0 or 1.1 release at this point. It's a bit too Java-ish, like I think some of the Java is leaking into the JSON here. So we need some work here to strip out some of the Java-ness. I think especially in the list, we argued about this, but there's some good news in this regard where we're going. So we get a list of the metadata. We get some templates, how to do a get. A get looks like this. A put looks like this, right? So a get is a get with a primary key. I can invoke named queries. So I have a named query here called employee count, and I can invoke that over REST. And you actually see the JPQL, which again is probably not a good idea in production to actually tell people what you're doing with your queries. So first you build it, then you make it a bit tighter, right? So I have named query. So I can do things like let's try this. Let's actually do the count. So I can click on the query, send it off, and I get 12 back. So we've made that query. If I look at the server console, here we are. We see a select count from employee where salary is, blah, blah, blah. Oh, from the two tables. It's spread across two tables. So you get you get a join. So that actually happened from me making a REST call. Now if I go back here, let's go back one, I think, and get the employee metadata again. I can do things like here, I can get employee, and I'm going to fill in this is the template. This is a REST client, right? This is just like me banging on REST, testing things out. Okay, so employee number 1 here is Eve Brown, female, and has links for relationships to her address. So I can click her address. I think she has one. And it's not found. I don't think she has an address, actually. 404. Nope, she doesn't have one. So the weird thing is, when I first started working with this, 404 scared me. When you get a 404, 404 means, yeah, there's nothing there. Don't worry. So I had to learn to relax. Let's just go back a step here. Employee number 1. So this is a full read-write API over REST, right? I have all these operations. I can query. I can manipulate the whole thing. And I didn't actually write any code. I did. I wrote the classes, but I haven't written anything to get this far. Where the work was now, of course, is building the application. So once you go from this, you start building applications. And so what I'm going to do is bring up the console. That's a good size. Okay. So this is the little EclipseLink employee application. It looks like every other application that uses Twitter Bootstrap. It's sort of like a generic-looking app now. And I usually give the disclaimer, I am not a UI designer. Okay, so please, I know. You'll see it does things, and you're like, why does it go there? Like, well, is better than console output, which you saw earlier. So if you like the console output in the early part of the talk, you've had that, and now we're going to have some graphical stuff. So I can do a search, and what I'm going to do is it takes 2 parameters. If you remember, if I go back up here, there's a find by name named query, and it takes parameters. And so what I'm able to do is, because we expose those queries over REST and we have a way, we've bound the we do parameter binding, I can go through here and say, let's do %%. I do a search, and I get a bunch of results back here. But looking at the console is informative. I love this thing, this console stuff here. So here's what we made a request for. Here's the URL. And you'll see that we have the parameters are passed here. Now, %25 is actually %. So it seems redundant, but first name is whatever, and last name is whatever. And over on the server side, you see that run exactly right. So that name query ran, and there's all the fields you want to get back, and the parameters are bound. So I can do that. I get back a response, which is a whole bunch. Well, actually, I think this is better. You get a whole bunch of stuff back. And so we've rendered them up here. Right? Go in and edit. Now, what was interesting about this, from a learning perspective, I guess here we are. So I went to number 1, and she does in fact have no address, right? It's 404. It does have phone numbers, however. What's interesting is that the address in this model is an entity. And so that means that when I fetch, and if you look here, and this is where things need to go to get better. So you see a request here for employee 1. So I said, let's edit employee 1. It fetched employee 1, but employee 1 doesn't have its phone numbers or address embedded in it. Those are different entities, right? So this is where it gets a bit chatty. So we had to go off and actually ask for the phone numbers. You see here, we actually got the phone numbers. This was using a relationship convenience reference here, and get the address. Again, on 404, not found, right? So the bad thing about this approach currently is that if you want to display a large number of resources on the same page, you have to fetch each one of them. But what I did in JavaScript was I actually fetched the employee. And actually, I don't really have it handy here. I fetched the employee, and then it has that link. I used the link to find the address, and then I actually replaced the link with the actual address. I actually, in the client side, built the domain model. I rebuilt it from my convenience, because it's easier in JavaScript if it's just a bunch of JavaScript objects, right? And made some changes here, so I can make changes to like the phone numbers here, whatever, and save it back. Here's the bad part. I shouldn't go back to this screen. I know. But you see, we saw the update to the phones go by. So what's interesting is we're actually supporting pass by value or pass by reference semantics, essentially. So if we were passing you everything by reference, we give you JavaScript or JSON with links. If you actually take the targeted object, the value, and embed it in the container and pass by value, we'll understand, oh yes, you're giving us the value that's associated. So you can make a very efficient return call. Unfortunately, you have to pull down the pieces individually and rebuild the structure if that's how you want to work. So, which I think takes us sort of to where we are with this. So that resource model, that's a big issue, right? So we have a very naive approach today, which is a JPA entity is a resource, right? Everything that's an entity, you can get it, you can put it, etc. The problem is that may be inefficient, right? So if it's the case that you really think that the resource model should be different. Now the weird thing is there's no way to define, there's no Java spec. I was been talking about this for like a few years now, complaining I have relational model, I have a Java model, I have a JPA mapping model, I have all these models. I don't have a resource model that's an existent thing in Java. In the Java EE specs, there's nothing on the JAX-RS side that describes what a resource or how to define a resource or anything like that. So what is a resource? We said an entity is a resource, but maybe 2 entities are a resource. Maybe you want to draw a box around these things. And I think this is what people do building REST APIs, is they decide, they sort of denormalize, as it were, the resource model to make it efficient for the use cases that they have to execute. So we're looking at, on the roadmap, a way to define or control what the scope of resource is, rather than just defaulting to this fairly naive and I think a little bit chatty approach. The second thing there is the format. So right now, the structure of those objects, if you go looking at competitors or other technologies, the formats vary. We're looking for sort of commonality or standardization. There are some technologies like OData out there, but that doesn't seem to have a lot of traction in the Java community. But this is open. This is why we versioned the APIs, because we know that going forward there will be changes to the structure, the layout, maybe some of the terminology, maybe the word link or relationships, whatever will change. And so we want to be able to make sure that you can safely use the old APIs and the new ones as they evolve. And the third thing, again, goes back to chattiness. Partial entities or sort of projections of entities. In JPA, you can do a select where you get three fields of an object. That's all you care for. So the question is, of course, if I'm building a nice JavaScript UI, and I really don't want this whole big object, it's massive, I don't need it, just give me three. So I want to be able to make a query and do what is on the server side or in JPA is sort of a fetch group, right? Just give me these three, please, or even a projection. Just give me a small amount of data and allow me to pass it back and forth so that I can optimize my communication with the server. So that's something that's on the list there. There's some work in that actually has been done. The third point here, though, the second big point is configuration. So right now, the URLs that I'm using, that I showed you and we're calling, is we define them and that's what you get. And we understand that if you're going to take a framework and put it in your application, you're going to want to shape those URLs to look like your application, right? You don't want it to look like, oh yes, these guys are using EclipseLink. No, you want it to be seamless. So some URL mapping is required. And I think a bigger issue is around I guess it's security in a sense, or exposure. Today we expose all the entities. Everything in your persistence unit will just automatically go and spin up REST services, but that's probably not what you want. And so we're looking at a way for you to specifically secure or expose or not expose entities that you may be developing. So you can decide this stuff should be exposed and this stuff shouldn't. And it makes sense. Like I said, the first goal was get it to work, and then we're trying to now tighten it up in terms of what you can do. And the last point is around metadata. So you saw that metadata that I was getting back in the browser over here. All this stuff, right? Oh, sorry, that's actually an employee here. Let me just pop back. I don't know where we are. Let's just try one. Yes, metadata for employee. Okay. So this format is fairly ad hoc. There's JSON schema. We started looking at JSON schema. Of course, it's not a standard. Like we could describe the REST APIs with JSON schema, but there is no standard for that. It's kind of a de facto, but I don't really know how much traction it has. Swagger is certainly possible. People have seemed to like the idea of using Swagger to describe things, so we can have nice Swagger like automatic documentation with nice testability, etc. with Swagger. But we're quite open in this regard. We understand that we would like to support standards. We just wish we had one that we could follow. So that's something that's going to evolve also. So this brings us near the end here. So this is my route, right? This is my goal. I want to build thin server architecture applications. I want to take database data using Java. I want to get over to the browser, manipulate it in JavaScript, Dart, whatever, send it back over, get it back in the database, right? Securely, not lossy, and efficiently. So we've pretty much built that. What we have today does the job. It may not be a final product, but it's certainly doing the job. So to summarize, the Java EE stack, and you saw me using all these various technologies in the stack, it's most of what you need. And I say most because things like the loop detection in JAXB isn't there. JSON binding especially is not there yet, right? JSON binding is something we can look forward to. But to build these sort of thin server architecture applications, you have pretty much what you need. You do have to be aware of the impedance mismatch, which was the terminology we used to say, the mismatch between relational and Java. Well, there's a mismatch between Java and XML. There's all these different impedance mismatches. And what I would hope is that going forward, the EE spec leads work together, right? So they work very hard on their individual specs, but as developers, we take a stack. We don't take a spec. Like we do, a little bit of JAXB to write a file, whatever, but really when you stick JAXB, JPA, JAX-RS together in a stack, they should interoperate, and they should be seamless, but today they're not seamless. So you kind of have to sand off the rough edges, and what we're trying to do is do a little bit of that for you, is like, work out some of the rough edges. But I would really hope that in the future, that we see a little bit more focus on the stack and not just on this individual specs, which we do, which is, is difficult given time constraints, I'm sure. So EclipseLink, you can download it from EclipseLink. Actually, EclipseLink.org, I think EclipseLink.com, I think we have all those. But eclipse.org/EclipseLink, you've seen here today that we have this feature at JPA-RS to integrate JAX-RS, JAXB, JPA. You saw me not have to write any code, which I think is great when you're doing a demo too, no code. And I think this really helps build these kind of applications. So we're really interested in you trying these things out. Feedback, obviously we're open source. We take contributions, we take feedback, we have an active forum, so we're really interested in hearing your feedback, and I'd love you to try it, download it and give it a try. And I think if you download Glassfish 4, it's all in there. So everything that I've talked about is in Glassfish 4 and ready to go. So there shouldn't be anything else you need, actually. Okay, so I've got 5 minutes for questions or so. Oh, I have to give you the Oracle disclaimer. Please do not buy anything based on what I said. Okay, there. All right, back to that. We have some mics. If anyone has any questions? Oh, in the front? Yes? Which HTML code? Oh, we're not returning HTML though. We're just returning the XML or JSON, right? So those pages I built were hand coded. The HTML pages are hand coded. But we're returning this stuff, right? That's what we're returning, which is being usually parsed into JSON objects and then rendered on the screen. Did I get it right? I got a 404. If it's not found. Which other so which HTTP codes are being returned? I don't know what the full catalog is. I'd have to actually look. I don't think I've had to bother with it. But obviously 404 is the one you hit first, right? And well, hopefully not 500. But yes.
In your example, you basically get for many to one, so kind of like a simple model, at least in this example. Does this back and forth iteration also work to remove an element from?
Yes. So there's the question of removing of elements from collections. Yeah. So there's actually special support for that. It's really a tough problem. You can tell us, remove this item from this list, and we'll know to remove that one item. Because you're right, there's back pointers and we manage that, but we kind of have to know. So there are specific requests you can make to remove an element from a list. And it's a big problem, because if you just pass us back a list, if you actually pass us back the whole list, we'll figure out which one's missing and delete them. But if you just want to more efficiently manipulate the list, you can. Yeah. Yes?
How would you do server-side validation?
Server-side validation. So at this point, you can use bean validation. So all those JPA entities can have bean validation. So you could fail. So you could do a put, and the put could fail because bean validation on your JPA entities has failed. So that's what's nice about this. It is just JPA. So since JPA is integrated with JAXB, or bean validation, that's available to you. We did actually have, in the early days, we built support for EJBs. So we actually were taking EJB methods and exposing them over REST and doing all the parameter stuff with JSON. And we realized it was biting off more than we could chew right then. So we kind of backed off from that because it's kind of intense. But in that, you could have just, it's business logic. You could write your own custom validation, right? Beyond just bean validation. Yes? Oh, the code. Yeah, that code is checked in to, it should be mirrored on GitHub. It's in the EclipseLink examples. So under EclipseLink examples, I actually checked this all out today. And you see here, there's a bunch of them. So here's the root. So I checked this out. I called it DevOps. I checked out the EclipseLink examples project. There's a whole bunch of stuff in there. So I was showing you things that were in the JPA-RS, and in the JPA MOXY, the integration. So it's all in Git at Eclipse, and I think we're mirroring over to GitHub. If you Google up EclipseLink examples, I think you'll find a link to the Git repo. Yeah. Yes? What? The composite key. Yeah, there actually is support for that, and actually you didn't see it, but it happens. The phone numbers have composite keys. So the phone numbers, let's see here. If I go and get a phone number, actually an employee, let me see here. It's faster to go, if I pull an employee, this will be the fastest way to do it, I think. You'll see that we have a syntax for that. Right here. So you see there's 1 plus home. So we've got, I think, an ID and a type. So the composite is a two-part key. So rather than having just one there, we actually have a plus sign indicating component part 1 and component part, key part 1 and key part 2. And this is the syntax we currently have. So if I click on this, for example, I should be able to pull it back. Yeah, so pull this guy. So here's his ID, and he has a composite ID and type. So it's available. Okay, I'm out of time. So if you have any more questions, I'll hang around up there for a few minutes. And thanks very much for your time.